Let's begin connecting the dots so you can see the picture. The BP wells at Mississippi Canyon 252 in the Gulf of Mexico. Since BP was paying for genetic research to increase oil well flow and production, logic dictates that BP needed to apply a newly created microorganism or microorganisms produced by their alliance with synthetic genomics to the oil reservoir located beneath their Mississippi Canyon Block 252 lease in the Gulf of Mexico. According to BP's submitted U.S. Minerals Management Service application, there were to be 2 exploration, not production, but exploration wells drilled and capped, designated as wells A and B. Exploration wells are commonly used to inject or introduce microbial-enhanced oil recovery microorganisms and their nutrients into an oil reservoir for increased present and future production. The first exploration well had been partially drilled by Transocean in October 2009, but the Marianas semi-submersible drilling rig was damaged by Hurricane Ida and was removed for repairs in late November 2009. On February 3, 2010, the Deepwater Horizon semi-submersible rig began exploration drilling to complete the unfinished drilling operation of the Marianas rig. On February 13, 2010, BP informed the MMS that they were experiencing uncontrollable bursts of gas and large cracks at the base of the well. That was the reason they filed for and were granted a permit to abandon and cap the well the same day on February 13, 2010. Shortly after, Deepwater Horizon commenced drilling the other exploratory well for BP. We all know the result of the second drilling operation that destroyed the Deepwater Horizon rig on April 22, 2010. One fact that can't be refuted regarding both exploratory wells is the extreme gas pressures coming from the oil reservoir and the resulting cracks on the ocean floor. MEOR microorganisms can be applied to an oil reservoir where they grow between the oil and the well's rock surface to enhance oil recovery. As a byproduct of that metabolism, and as I just mentioned before, microorganisms produce carbon dioxide gas, and this gas accumulates and displaces the oil by driving it up and out of the ground. At the same time, microorganisms can break down the thickness or viscosity of the oil so that it's thinner and can flow much easier. The published commercial goal of the BP Synthetic Genomics Alliance was to create new genetically engineered microorganisms to increase the flow of oil. A public trademark of that research involves man-made genomes, synthetic DNA, controlling new artificial cellular organisms. Because of the vast estimated reserves of oil at Mississippi Canyon 252 in the Gulf of Mexico, the temperatures involved, and its extreme low oxygen depth, previous known or lab-enhanced microorganisms would not be effective in creating an increased flow of the oil. Now, one can only imagine what the results would be of a new MEOR synthetic bacteria that had a computer DNA design capability to replicate itself rapidly in such an extreme environment. The outcome would be unpredictable since it had never been tested in those conditions before. Or had it? Let's connect the dots to see more of this picture. Say hello to Cynthia. S-Y-N-T-H-I-A. In 2003, JCVI successfully synthesized a small virus that infects bacteria. By 2008, the JCVI team was able to synthesize a small bacterial genome. On May 6, 2010, JCVI revealed they had already created a self-replicating bacterial cell controlled by a chemically synthesized genome they called synthetic mycoplasma mycoides JCVI SYN 1.0. This completely synthetic cell with its computer-designed genome has absolutely no natural DNA. The ETC group from Canada named it Cynthia, S-Y-N-T-H-I-A, and it contains added watermark chains to identify the genome as artificial. It also has antibiotic resistance indicators. Now, one can only speculate why this artificial bacterium has an inherent programmed capability to resist antibiotics. This new life form has the ability to replicate itself and organically function in any cell to which it's been introduced. Its DNA is artificial, and it's this synthetic DNA that takes control of a cell and is credited with being the building block of life. This is the first self-replicating synthetic bacterial cell thanks to its computer-generated DNA. All the funding for this came from, guess who? Synthetic Genomics Incorporated. The company BP has a sizable equity position and alliance with. No, BP is definitely way beyond petroleum, just as their new slogan publicizes. Now, why watermark this artificial genome? Well, doing so makes it identifiable as the unique and patented or patent pending asset that it is. That means it's privately owned. So what happens if a human becomes infected with a life-threatening variant bacterial species of Cynthia? Well, if you use penicillin to fight the infection, it won't do any good. Antibiotic resistance is an inherent part of its DNA sequence. So any use of antibiotics would be a waste of time. What would happen if mankind is contaminated by the self-reproducing artificial life form by contact or by breathing it? Would we become subjective to the DNA of the synthetic cells flowing through our bodies? Would these Cynthia cells combine with other bacteria within us to create a new deadly bacteria? Since a microorganism is created and gets its programming from computers, would we become subject to artificial electromagnetic frequencies only recognized by these genomes? There are a lot of questions that need to be answered. But what matters most is this: will we find out those answers in time? Let's keep connecting the dots. I think the picture's starting to take a little bit of shape now. So how do we get rid of all of this oil? The oil is there deep in the Gulf of Mexico. It's not going anywhere. It has a continual supply. There are no plumes of oil. There are deep lakes of oil. In a True News Radio interview with Rick Wells on June 28, 2010, the late oil industry expert Matt Simmons stated, BP claimed to have the only technology to deal with this when asked why the U.S. government wasn't taking over the Gulf oil crisis. Considering their 3-year alliance with synthetic genomics and the genetic creations they've made, it's very possible that the U.S. federal corporation in D.C. was convinced that BP's breakthrough genomic technologies were the better gambling odds. There had never been so large an amount of crude oil to deal with before. Now, for decades, scientists have eagerly pursued genetic modifications that would enhance natural microbial abilities to eat up oil spills on both land and sea. Even with DNA recombinance and bacterial gene splicing, there's been little positive success with improving on nature's natural oil eaters. Although his announcement silently slipped past the ears of news reporters from around the world, JCVI and synthetic genome founder Craig Venter foretold of and spoke openly of just such an application on May 15, 2010, during the public announcement of what the press is now calling Cynthia. He was referring to a Cynthia-based synthetic bacterial cell that would consume hydrocarbons, or oil, more efficiently than any known natural microorganism. You know, it's worthy to note that one of the first patents on a genetically engineered organism was a hydrocarbon-eating microbe in 1980 called the oil eater. That microorganism was actually a naturally occurring bacteria that had been given 4 rings of DNA that were also naturally occurring. This gave the bacteria the ability to degrade 4 components of crude oil. Now that was back in 1980. A lot has changed since. Scientifically, there have always been problems with trying to take command of a natural microorganism. They're too unpredictable in diverse environmental conditions. While they do their job well in certain conditions, they can become dormant in other ecological surroundings. Marine chemist Chris Reddy of the Woods Hole Oceanographic Institution said that microbes are a lot like teenagers because they're hard to control. In contrast, artificial microbial life forms, like Cynthia, are controlled by their computer-created DNA programming. Microbial ecologist Kenneth Lee says that only microbes can remove the oil from the ocean, and that biodegradation is what removes most of the oil from the environment. History proves the statements are correct, but the time involved can span many decades and beyond. We don't have that much time to deal with the oil in the Gulf.